there are two ways you can go about this. Okay, the first one was the formula that you had yesterday. It was like the x was x1 plus k for like the x coordinate, and then you repeat it again for the y. Okay, and doing that way, you just have to have the right k value. Even for the other way, you still have to have the right k value. And keep in mind, right, the way that I have that ratio written, the 1 to 3, means that you want to put a point somewhere in here. Let's just say there's one right there, so that this portion of it is, like this segment here, is 3 times the length of that one. So that these are in ratio of 1 to 3. Okay, now that means that the k you should use is 1/4. Because you got to add them together. Because again, if I'm breaking it up again so that this is like 3 times the length of that one, if I put 3 and 1 together, that gives me 4 for the entire thing, which is what this is related to. All right, so you can either take the coordinates like you have there, or if you want to see an alternate way to do it, another way to do it is just look at how far horizontally and vertically you have to go to get from one point to another. So if I look at this and I count these out, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to get over there. And if I count this down, it should be 1, 2, 3, 4, 5, 6, 7, 8 to go down there. If I scale those two numbers back and I use that as like a slope kind of thing, where you count like rise and run, it's also going to take me to where the point is. It's just if the answer is asking for the coordinate, you would then have to go to the graph and pull the coordinates off of it. So if I take this k value and multiply it by those two, so 12 times 1/4 is 12 divided by 4, which what's 12 divided by 4? So if I go this direction, 1, 2, 3, it's going to tell me how far horizontally I should go to get to where that point that they want it to be. That's going to break it up into, or it's going to partition it into the correct order. And then this one here, what's 8? So again, I would do the same thing for this. 8 times 1/4 is 8 divided by 4, which is what? So then I would go down 2, right? Because again, this right here is this number times the k value, and that's that times the k value. So that point right there, which was -4, 4, would be one of the answers that you can get. You would get this. Okay, so on page 18, this should be there. All right. If you were to fill these in, obviously this part is related to that graph, and those are related to that graph right there. They give you the word there, so you know these lines are parallel. If you forgot the symbol from the other day, the symbol that you use should just be, looks like an extended 11. So if I called this is line 1 and line 2. They have them listed there, so you would write it like line 1, line 2, and put the little parallel symbol in between them. Another thing you're going to see is on these lines, these little arrows right here, the reason they have those is that's how you indicate on like a picture which lines are parallel to each other. So on the actual diagram, if you see a line with an arrow in the middle of it or just off to the side, somewhere on the inside of it, the reason it's there is to let you know it's parallel. So this little bit right here means parallel. Okay. Perpendicular doesn't have any symbols like that on the lines because remember, perpendicular means it's making a right angle. The symbol, if you forgot, that was the upside down T. So in the case that's over there, they've got these two listed as line 3 and 4. So you'd say line 3, line 4 are perpendicular to each other. So again, no symbols on the actual lines, but since they make a right angle, you'll see sometimes the box that's in there, just indicating that they are making a right angle. And anytime we're doing anything with angles, if you see a box anywhere, that's telling you that that thing is a right angle, which is 90 degrees. For you to find the slope between 2 points, okay? Before I write out there, what do you guys know about slope? Don't give me I don't want like y equals mx plus b, because that's the equation of a line. How do you find slope? Shout it, I don't care. What? Come on, you're reading me for me. It's right. How else can you find it? What was that? Wait, who said it? No, who said something else? Yeah. Alright. Any of that, those are like the two main ways. The rise of a run thing is going to only affect you, or you would only use if the thing is graphed out. Alright? This one would be used if you have the two endpoints or 2 points that are on the line, so you actually have the coordinates that are given to you. You would use this formula. If it's already graphed out, you can pull coordinates off and use this, but more than likely, if I was looking at, say, this line here, instead of me picking 2 random points and plugging it in, I would just try and count. You would find, if you're going to do the counting, you would find parts where the line is going through an intersection of your grid. So like from there to maybe right here. Okay? And keep in mind, right, the positive and negatives matter. So if you're going up, that's positive. To the right is positive. To the left is negative. And down is also negative. And just in case you forgot, the M is there, because M is always the letter you use for slope. So lowercase m is always slope. But if I was counting this one here, if I go, it doesn't matter which one you want to start. We'll call this A and B. Do you want to start at A or B?
B.
B? Fine. So to go from B to A, I've got to go up. Was that 1, 2, 3, 4? So that's a positive 4. And I got to go to the left 2. So that's a negative 2. Which one's the rise? Which one's the run?
The rise is 4, and then run is 2.
Good. Rise is always up and down. Run is always horizontal. So that, and then if you can reduce them or divide them out, do it. What's 4 divided by negative 2? Negative 2. So the slope of this line right here, negative 2. All right, what's that? The slope of line 2. If you want to do the coordinates, that's fine. I would have just had to make this point the coordinate 4, 0. This point up here, 2, 4. And then taken the 2, 4 and the 4, 0 and plugged it into my slope formula here, which would be my 2 y coordinates were 4 and 0. My 2 x coordinates were 2 and 4, which again would get me back to the 4 on top and the negative 2 on the bottom. No matter how you do it, whatever you're comfortable with is the way you need to stick with. This will work every time. This will work only if it's graphed out for you, or if you want to take the time and graph something out, then that'll work. All right, so for the parallel lines here. Okay, so for the parallel lines, how did the slopes act with each other? They were the what? They're the same, right? Should always be. So these have same slope. For right now, this is how you are going to verify or prove that 2 lines are parallel to each other. You're going to find the slope of both lines. You're going to make sure they're equal to each other. Okay? So if they gave you these 2 lines and they said, hey, I think they're parallel, but I want you to show me that these 2 are parallel to each other, you would find the slope of this line here, which we already did, right? This was, what was it? Negative 2, right? Right, because that was 4 and that was negative 2. So the slope of this one was negative 2. So again, if the problem wants you to either verify or prove or justify any of those words that 2 lines are parallel to each other, you're going to find the slope of both lines. So that one was negative 2. And if I do this one, is that crossing there? 3, 4 to there. It's going to be the same because I go up 4 and then to the left 2. So that also is going to give me a slope that is negative 2. So you're going to have to be able to reduce fractions with this stuff, guys. You're going to have to be, if you don't want to do that, you're going to have to make them decimals and make them exactly the same decimals. Leave them as fractions, though. Because the majority of the problems are going to want these to be in fraction form. Right? And as soon as I got to this point, I would say, hey, that verifies those 2 lines are parallel to each other. All right, so for the perpendicular ones, how do the slopes act there? They're what? Different, but how are they different? Opposite reciprocals, right? So opposite means that the sign should have been different. So on that second one where you're just, if you were sliding this thing around, you should see that the fractions are going to be reciprocals of each other. So opposite, reciprocal. So if one of these was like 5 over 6, the one perpendicular would be 6 over 5, but one of those would have to be negative to create the opposite part. So again, opposite deals with the positive negative part. Reciprocals just means that the fractions are flips of each other when you do the slope. And keeping in mind things like if I had a slope that was a negative 4, the reciprocal of negative 4, or opposite reciprocal, would be a positive 1/4, because 4 is 4 over 1. Sometimes people forget about that, but you still have to flip the whole thing, and just keep in mind whole numbers have a 1 underneath it. We just don't write it, because when you divide something by 1, it's itself. All right, so you guys are going to extend this into equations and lines. So I'm going to write, there's 3 up here. You can write them down. The equations of the lines that you guys are working with, I'll tell you when to use each one. There's 3 of them. Slope-intercept form is the common one that everyone remembers. The good thing about slope-intercept form is if you have an equation of a line written in this form, and to have something in this form, it has to be y equals some number times x plus another number. It could be 0, 1, 2, it doesn't matter. But the y has to be sitting completely by itself. So if you're working with an equation and there's like a 3 with it, to get it in this form, you'd have to divide the whole thing by 3. So slope-intercept form is only going to work if there's a single y. The good thing with having this is that if it's in this form, you can look at the number in front of the x, and you automatically know what the slope is. And you can look here, and you can automatically tell where it's crossing the y-axis. What we're going to be more concerned with right now, since we're dealing with parallel and perpendicular lines, is going to be this number. So again, the idea is if I want to prove that lines are parallel or perpendicular, I have to look at the slopes, and if the slopes are the same, they're parallel. If the opposite reciprocals are perpendicular, if it doesn't line up to either one of those, they're neither. They're just lines that cross at some point. Nothing special about them. So if I need to like pull slopes out, that's the form you want it to be in. The next one is one that if you're writing the equation of a line, meaning that I give you a couple points and I want you to write the equation of a line between the 2 points, it's generally easiest if you use this form right here. This x right here, this y right here, always stay x and y. The point of having an equation is so that you can use it as a function where you can plug a number in and it can tell you like a number that comes back. Like you put an input in, it gives you an output. Same thing up here, right? And with slope-intercept form, this y and this x are always y and x. And then you put numbers here and here. In the point-slope form, this y stays the letter y, that stays the letter x. y1 and x1 represent some point that is on the line. This is the x-coordinate for that point that's on the line. That's a y-coordinate. That still means slope. So you'll have, when we're doing the equation of lines, which I'll do a couple problems, you'll put a number here, here, and here. Okay? The last form, which probably is something that you're going to use in passing, works best. This is good if you want to do a lot of graphing, because you can find intercepts with this real fast by just kind of combining those numbers in the C and A. You can get an x-intercept and a y-intercept. And if you're graphing things out, if you just go to the axes, it's easier to put points there than to count off points somewhere on a plane. And there, A, B, and C are numbers. The x stays in x, the y stays y. If you put numbers in x and y, you're solving it out, or you're finding like an output for a certain input. If you're doing an equation, you need variables in there. or else you're not writing an equation, you're just writing a number. Y-intercept and point slope are the two biggest ones you're going to work with. All right, so I'm going to do two problems. The first one is, these are both should be in that book. I didn't write down what page they're on. I'm assuming if that thing was on 18, is it around like 19? 18? There you go. Okay? Well, these are on 18. The next one will be on 19. Okay? All right, so the question here is saying, or it's asking, you want to verify or see if the lines are either parallel, perpendicular, or neither. So now again, like I said, the thing you're looking at and the thing you're working with is going to be slope. You want these equations in slope-intercept form if you're doing a problem like this. So keep in mind, right, slope-intercept form was that. This is 1y. You want to have nothing else with the y there. You just want it to say y equals mx plus b. This is going to be the number we're concerned with. The only time we'd be worried about this number out here is if when you put it in slope-intercept form, they end up being the exact same equation, then it's the exact same line, and that can't be parallel to each other or perpendicular or neither. It's on top of each other. So when you're doing problems like this, put it in this form and just look at that m right there. Okay? So if I went through these, I'll do a couple of them. And since A's up there, we'll start with B. I'll do B. We'll talk about B, C, and D. All right, because that's a good one to also make notes with. On all those right there, like especially for B and C, the equations that they give you, the two you're comparing, are not in this form. So you have to use algebra to kind of rewrite it that way. I need my y on one side, I need my x and the constant on another side. And then once I get that part, I've got to divide everything by whatever number's in front of y so that I have it in the proper form. So this equation right here to start with, the 2x minus 5y equals 10. My first step would be move that 2x to the other side so that now I've got my y's on one side, the x and the constant on the other, and then divide everything by that negative 5. So that when I say divide everything, I means every term. Now again, the b at the end doesn't necessarily matter. All that's going to matter is that if we were trying to see if the equations were exactly the same as each other. So what happens is negative 5 divided by negative 5 is 1. Negative 2 divided by 5 is just, or negative 5 is a positive 2/5. And 10 divided by negative 5 is negative 2. So now I've got the equation in slope-intercept form, meaning that I can look at this number. There's my slope. There's my y-intercept if I needed it, which I would probably only need if I was graphing it out, or if for some reason this next equation ends up being the exact same y-intercept. All right, so I'm going to do the same thing here. So I need this to be, that 10x has to go to the other side. Then I got to divide everything by the 4 so I can just have y by itself. What's 20 divided by 4? Okay. Make sure you reduce fractions. Of course, I did not do that yet because 10 over 4 is still 10 over 4, but I need to reduce it down. If I reduce 10 over 4 down, the top and the bottom can be divided by 2. So I can change that so it's like, what's negative 10 divided by 2? 5, right? What's 4 divided by 2? 2. Negative 5. Okay, so the y-intercepts are different, so I don't even care about them anymore. All I care about are those two numbers. Which if I've got 2/5 here and a negative 5 over 2 here, that means that those lines are perpendicular to each other. Because the slopes are reciprocals and they're different signs. So again, all I cared about was this, but I couldn't look at the slopes until I have it in this form first. If you don't put it in slope-intercept form, you can't just use you just can't pull the slope right out. Unless you get savvy with it, which you could do it a little quicker.
Which is double that.
Nah.
You double everything in the equation.
Okay. You want me to do it the long way again, or show you a shorter way? Longer way or shorter way?
Short.
Shorter one harder.
No. All right. So if I looked at the slopes here, okay, let's focus on these two numbers up here. This 2, where did it come from in this equation?
2x.
From here, right? Where'd that 5 come from? 5y. Only difference between this here and this here with the numbers is you change the sign. If I go about the same thing, I can take, what is that, a 4? Is that a 4? Yeah. So I can take the 4 that's there, right, and the x one on top, the 3 that's there, change the sign, and I'm telling you right there, that is the slope of that line. Okay? So look, the reason is because if I go about doing, if I go through the process of doing my slope-intercept there, let me put this off to the side. My process would be subtract 4x. And I know there's a 63 there. I'm just going to ignore it for a second. And then what do I do? Divide by 3. Your process is always going to be move the x to the side and divide by that 3. And that's always going to be the two numbers. These two numbers here are always going to be divided by each other. The only difference is because you have to move the x to the other side, you're going to change the sign of it. Okay? If I did the same thing here, my slope here is going to be, that number's in front of the x. If I change the sign because I have to move it, that negative 9's in front of the y. What's that? Can someone reduce that?
It would be 4 over
3.
3.
So I'd be looking at, not y. Oops. I'd be looking at, here it is, this slope here and that number right there. Are they the same? What? No. One's positive, one's negative. It's not the same. And they're not reciprocals of each other, correct? So this one here is going to be neither.